Hello, I am Sujit. Welcome to Physics 2020. So today in this section we are going to discuss some of the numericals of projectile motion in an inclined plane. So this is the third section in this topic, that is projectile motion in an inclined plane. So in the first topics we have discussed the very fundamentals of projectile motion in an inclined plane. So what is the horizontal component of velocity, what is the vertical component of velocity in the inclined plane, and what is the acceleration due to gravity, that is g vector. Okay, so along the vertical direction and horizontal direction we have discussed. And in the second section we have derived the formula for time of flight, maximum height and horizontal range. Okay, horizontal range. So go through the videos of the previous sections and try to remember, that is, try to understand the concept, okay, concept or theory, then only you can solve the numericals. Okay. So first numerical, question 1. Question 1. So consider an inclined plane. Okay, inclined plane. Of angle 37 degree. Okay, 37 degree. So this is the x-axis and this is the y-axis. Y-axis. So an object is projected from here, okay, projected from here with the initial velocity, that is 10 root 2. U is equal to 10 root 2. Okay, 10 root 2. So with the angle, that is 45 degree. 45 degree. Okay, so find 1. Time of flight, 2. That is maximum height, 3. That is horizontal range, horizontal range. Okay, so this is the problem. So consider an inclined plane which makes the 37 degree with the horizontal. Okay, horizontal. So an object is projected from here with the initial velocity, that is 10 root 2 at an angle of 45 degree with the inclined plane. Okay, so we have to find the time of flight, maximum height and horizontal range. So here what is theta? So here that is theta is equal to, yes, 37 degree. Okay, theta is equal to 37 degree. Theta is equal to 37 degree and alpha is equal to 45 degree. Okay, 45 degree. So this is the horizontal component of velocity, that is, okay, horizontal component of velocity, that is u cos alpha, and this is the vertical component of velocity. Okay, vertical component of velocity, that is u sin alpha, and this is the vertical component of acceleration. Okay, vertical component of acceleration, that is g cos theta, and this is the horizontal component of acceleration, that is g sin theta. Okay, g sin theta. So we have to find time of flight. So how we are dividing these components means, you can watch the first video. Okay, if you want to understand this, that is how these components are divided. So if you watch the first video in Physics 2020, you can understand that is projectile motion. Okay, projectile motion in an inclined plane. So time of flight. So the formula we have derived. What is the time of flight? So T is equal to 2u sin alpha divided by g cos theta. Okay, so this is the formula for time of flight. So that's equal to 2u. So we can substitute, that is 2 into, what is u? That is the initial velocity, that is 10 root 2 into sin alpha. Okay, sin alpha, this is alpha 45 degree. Okay, sin 45 divided by g, that is 10 into cos theta, cos 37. Okay, so cos 37 is a famous triangle. So I already discussed that triangle, cos 37. Okay, this angle is 37. Okay, 37 degree means that is 3, 4 and 5. These are the sides. Okay, triangle. Okay, 37 degree means these are the sides. Famous triangle. Okay, 3, 4, 5. So that's equal to 2 into 10 root 2 into sin 45 1 by root 2 divided by 10 into cos 37. So adjacent side by hypotenuse, that is 4 divided by 5. Okay, 4 divided by 5. So 10 get cancelled, root 2 get cancelled. So that's equal to 2 into 5 by 4. So 2 get cancelled. So that's equal to 5 divided by 2. That's equal to 2.5. This is the time of flight. T is equal to 2.5 seconds. So direct formula, direct substitution. Okay, direct substitution. So time of flight, we have derived the formula, that is 2u sin alpha divided by g cos theta. Alpha is the angle of projection in the inclined plane and theta is the angle of the inclined plane with the horizontal. Okay, horizontal. So 2u sin alpha divided by g cos theta. T2 into, what is the initial velocity? That is 10 root 2 into sin 45. So alpha is equal to 45 into g cos theta, 10 into cos 37. So cos 37 means you have to remember this triangle. Okay, so 37 angle means the side must be like this, that is 3, 4 and 5. Okay, so t is equal to 2.5 seconds, you will get the answer. Okay, so t is equal to 2.5. Okay, so second thing we have to find. What we have to find? That is maximum height. Maximum height. Maximum height. So maximum height, what is the formula? That is h max. Okay, max height. Suppose the projectile is like this. What is the trajectory of the projectile? So u is equal to this is the trajectory. So u is equal to, that is 10 root 2. 10 root 2. Okay. So this is the maximum height. H max. H max. So H max equal to formula u square sin square alpha divided by 2g cos theta. So we have derived the formula in the previous section. Okay, go to the video. It is projectile motion. Okay, inclined plane. So h max equal to u square sin square alpha divided by 2g cos theta. Okay, so direct substitution, that is u square 10 root 2 the whole square into sin square alpha sin 45. Okay, sin square sin 45, what is the value? That is sin 45, that is 1 by root 2 the whole square. So divided by, okay, divided by 2 into 10 into cos theta, okay, that is 4 by 5 u square sin square alpha divided by 2g cos theta. So u square 10 root 2 the whole square into sin 45, okay, sin 45 the whole square, 2 into 10 into, that is cos theta, okay, 4 by 5. So that's equal to, so 10 root 2, that is 10 square 100, root 2 the whole square 2, that is 200. Okay, so 200 into 1 by 2, so that's equal, divided by 2 into 10 into, that is 4 by 5, okay, 4 by 5. So cancel, it is 100 times, so 10, it is 10, okay, 10 times. So that's equal to 10 into, we can write, that is 5 by 8, so 5 times, so 4 times, okay, 4 times. So that's equal to 25 by 4, okay, 25 by 4. So 6 fours are 24, okay, 6 fours are 24, balance 1, so 10, 2 times, okay, 2 times, 2 times 8, so balance 2, 20, so 5 fours are 20, so that's equal to 6.25 meter. So this is what, that is h maximum height, okay. So h max equal to, is equal to 6.25 meter. So h max equal to, it is 6.25 meter. Clear? So direct formula, direct substitution. Clear? So the next one we have to find, that is horizontal range. So horizontal range also we have derived the formula, that is in the previous section we have derived the formula, but we don't use that formula, okay. So according to the situation or according to the problem we will use the concept, okay, that is horizontal range. So what is horizontal range? That is an inclined plane, horizontally how much distance the object has moved, okay. So this is the horizontal range. So horizontally how much distance it has moved. So this distance gives the horizontal range, okay, horizontal range. So this much distance, okay. Yes, this much distance is the horizontal range. Horizontal range. Clear? So we are considering the horizontal distance, okay, horizontal motion of the object from horizontal motion. So in this motion, that is the projectile motion, whenever the projectile motion is considered, there are two types of motion, that is horizontal motion and vertical motion. So the combined effect of horizontal motion and vertical motion is that is projectile motion, okay. So I am considering that is a horizontal motion of the object, okay, horizontal motion of the object. So I am using the kinematic equation, that is S is equal to ut plus half at square, okay. So I am rewriting this equation, that is Sx, because this equation in the horizontal direction. So Sx equal to Ux. Okay. So U suffix x t plus half Ax t square. So what is Sx? So this much, how much displacement it has moved. So when the projectile starts from here and it terminates here, okay, terminates this point or ends point, end this point. So how much horizontal distance it has moved? Okay, so this much distance. So Sx is nothing but that is r is equal to Ux. What is Ux? That is U cos alpha. That is U. That is 10 root 2 cos alpha. Okay, cos alpha. Cos 45 plus half into acceleration in the vertical, acceleration in the horizontal direction. So that is g minus, okay, minus g, value of g is 10, sin theta, that is sin 37, sin 37. Okay, so here we have to put, that is writing that. So okay. Sx equal to, that is r. Okay, r is equal to Ux, that is U. What is Ux? That is U cos alpha. Okay, U cos alpha. That is the velocity in the horizontal direction. U cos alpha. Okay, U cos alpha. So Ux means, that is U, x is U cos alpha. Uy means, that is U, yes, sin alpha. Okay, sin alpha. So U, what is the value of U? That is 10 root 2. 10 root 2. Cos alpha, that is cos 45. Cos 45 into t. So that is the time of flight. That is 2.5. So for the whole motion, okay, whether it is a vertical motion or horizontal motion, that is the time of flight is same. Okay. So the from this point to this point, what is the time of flight? That is 2.5 seconds. We have already found 2.5 plus half into, come on, half into Ax. So Ax. So Ax means, that is g minus g sin theta. Ay means minus g cos theta. So we have thoroughly discussed all these things in the previous video. Okay. So half into minus g sin theta. Okay. So minus 10 into sin theta, sin 37 into t square, that is 2.5 square. Clear? So that's equal to 10 root 2 into cos 45. Cos 45, that is 1 by root 2 into 2.5. So plus into minus. So this minus we can take outside. So minus 1 by 2 into 10 into sin 37. Opposite side, sin 37, opposite side by hypotenuse, that is 3 by 5. Okay. Opposite side, that is 3 by 5. 3 by 5 into 2.5 square. So 25 square, that is 625, that is 6.25. 6.25. Clear? Right. Right. So root 2 get cancelled. 10 into 2.5, that's equal to 25 minus, okay, minus. So 5, 2. Okay, so this 2 get cancelled. So 3 into 6.25. 6.25 into 3. 5 3s are 15, 1. 3 2s are 6, 7. So 6 into 3, that is 18. So 18.75. Okay, 18 point minus 18.75. So 25.00, 18.75. So 10 minus 5, 5, 9 minus 7, 2. Okay, so 14. Okay, 14 minus 8, that is 6. Okay, 6. So that's equal to 6.25 meter. That is horizontal range. Okay, horizontal range, that is R. So we have to find the three values. Time of flight, that is 2.5 second. Okay, so that is the answer. Maximum height, h max equal to 6.25 meter, and horizontal range, R is equal to 6.25 meter. Clear? So understand the concept. So the first two things, time of flight and maximum height, we have used the formula. Okay, so and direct substitution. And horizontal range, that is we have used the concept. Okay, that is by considering the horizontal motion of the object, and we find the answer. Clear? So second question, a projectile is thrown with a speed u at an angle theta to an inclined plane of inclination beta. Find the angle theta at which the projectile is thrown such that it strikes the inclined plane normally. So it is an inclined plane. Okay, inclined plane of inclination beta. Okay, it is given beta. Okay, so this is our x-axis and this is our y-axis. So particle is projected from here with initial velocity u at an angle theta. Okay, at an angle theta. So find the angle theta at which the projectile is thrown such that it strikes the inclined plane normally. So when the projectile reaches the inclined plane, so it should reach the inclined plane normally. So for that, what is the angle of projection we have to find? So what is the trajectory of this? Suppose if you draw the trajectory of this projectile, okay, it is like this. So at each and every point, that is each and every point, it has what? Two velocity, that is horizontal component of velocity Vx and vertical component of velocity, that is Vy. So this is the resultant velocity. So here, that is the angle of hitting. So the angle of hit with the inclined plane is not 90 degree. Okay, not 90 degree. Suppose if the projectile has to hit, that is in the inclined plane normally, means the vertical, that is the horizontal component of velocity must be 0. Okay, that is Vx must be 0. That is the condition. Okay, so Vx equal to 0. This is the condition for hitting, that is the projectile in the horizontal direction, normally. Okay, so I will show you. This thing is 90 degree. Okay, 90 degree. So in this case, that is only the vertical velocity, not the horizontal velocity. It should have only the vertical velocity. The horizontal component of velocity must be 0. Okay, must be 0. So then only the particle or the object hits the inclined plane normally. Okay, normally. So I am using the kinematic equation, that is So for that, what is the angle of projection we have to find? Okay, what is the condition for angle of projection from the given details? Okay, given data. So I am using the kinematic equation, that is V is equal to U plus AT. So I am rewriting this equation, that is Vx. Okay, Vx. V suffix x equal to Ux plus Ax into T. So here what is Ux equal to U cos theta, Uy is equal to U sin theta, So these are the things we have discussed, okay, in very detail in the previous sections, okay. So how to find the horizontal component of velocity and vertical component of velocity. So Ax equal to minus G sin theta, Ay is equal to minus G cos theta, okay, cos theta. So here what is T? T is the time of flight, okay, T is the time of flight. So T is equal to, capital E is equal to 2U sin theta divided by G cos beta, okay, T cos beta. So this Vx equal to 0 is equal to, what is Ux? That is U cos theta, plus what is Ax? Minus G sin theta, okay, into T 2U sin theta divided by G cos beta, okay, that is 0 is equal to U cos theta minus, so this G cancel, okay, this G cancel. Yes, here not sin theta, that is G sin beta and G cos beta, because the angle of inclination, okay, angle of inclination, that is beta. So here also that is minus G sin beta, okay. So G get cancelled, sin beta by cos beta, that is tan beta, okay, tan beta. We can write, that is yeah, I am writing like this, it is minus 2U sin theta, okay, 2U sin theta, sin beta by cos beta, that is tan beta, okay, tan beta. So I am bringing this minus term the left hand side, that is we can get, that is 2U sin theta tan beta, okay, is equal to U cos theta, okay, U cos theta. So U get cancelled, okay. So 2 tan beta is equal to cos theta by sin theta, right. So cos theta by sin theta, that is cot theta. Cot theta is equal to 2 tan beta, okay. So theta is equal to cot inverse of 2 tan beta. So this is the condition for angle of projection. So we have to find, that is find the angle theta. So we have to find the theta at which the projectile is thrown. So from the given data, so what is the condition we have to find? So what is the angle of projection such that it hits the ground, that is hits the inclined plane normally. So we are using, that is the inclined plane. When the projectile hits the inclined plane, it also has two types of velocity, horizontal velocity and vertical velocity. So horizontal velocity and vertical velocity means it won't hit the projectile, that is inclined plane normally. Suppose if the projectile wants to hit inclined plane normally, means the horizontal component of velocity, okay, horizontal component of velocity must be 0, that is Vx equal to 0, that is the condition. That condition we are using. So I am using the kinematic equation V is equal to u plus apt. So Vx equal to ux plus ax into t. So substitute all the values, and for the time, that is time of flight, so we are deriving this, that is theta is equal to cot inverse of 2 tan b. So this is the condition for, that is hitting the projectile in the hitting the projectile in the inclined plane normally. So these are the two sums we have solved in this section. Okay. So stay tuned. So we will come with the new topics and new numericals. Thank you.